All right, so I apologize for the background noise. I'm printing something off my printer and it takes forever, so I'm kind of just getting the ball rolling and continuing. So hopefully this doesn't bother you too much, but go ahead. Here's a warm up from the last lesson. Write this as a conditional statement. So all birds fly. And then also write this as a conditional statement. Supplementary angles always have one acute angle. All right, so you write this one as if it's a bird, then it flies. Okay, over here, supplementary angles always have one acute angle. If there's a pair of supplementary angles, then there is, at least one acute angle. Sorry, my handwriting's so bad. Okay. It's just saying, if there's a pair of supplementary angles, then there is at least one acute angle. Now, is this statement true? Most of the time, yes. Okay, so like what they're saying is, if there's a linear pair like this, one of them has to be acute. But there's one, what do you call it? One example, a counterexample, where both of them are right angles, so they're not acute. So not always they have to be acute. All right, so here's inductive reasoning versus deductive reasoning. So that's what this lesson is going to be over. So inductive reasoning is patterns, observations, examples, trials. Okay, inductive is math. Okay, mathematical theory or generalization. So it's just a conjecture, like this is a guess, okay? I'm just making a guess, like, okay, this is, supplementary angles have one acute angle. That's just a guess for something. Now for deductive reasoning, this is more of what we're going to be doing in this unit, where we're going to take laws, facts, axioms, theorems, logic. Okay, so it's a bunch of facts that leads to a set of arguments that forms a conclusion. Inductive is just a generalization. Deductive is a conclusion using definitions, theorems, axioms, laws, facts. Okay, so if I had to pick between these two, which one would be more reliable? Deductive all the way. Okay, so deductive is more reliable. Inductive is kind of just a skeptical, I think my printer's done, yay. It's just a conjecture, which means, okay, it's a theory. All right, I'm just coming up with a theory. So let's go ahead and here are two different examples that kind of help you see this. So the first example is Mr. McCain drove his car into a lamppost. Okay, some examples of inductive reasoning would be, okay, he drove poorly for the in 4 of the past 5 days. So we've just kind of seen by observation, okay, he's driven kind of bad. We saw him swerve to miss a bus yesterday. He has hit 5 lampposts in the last year. Okay, so the conjecture would be Mr. McCain drove his car into a lamppost outside. So these are just kind of based on past experience right here. Now, deductive is more facts that has to do with the exact date of occurrence. Okay, so his wife saw him leave the house with his car undamaged. Now he has a dent in his car. These are facts. The lamppost was broken at 6:30 a.m. and he was the only one there. Okay, so these are very much like, okay, these are obvious, like, these are facts having to do with exact example. Okay, so Mr. McCain drove his car into a lamppost. Versus these are based on past experience. All right, so over here to the example 2, this is more math, right? Example 2, obtuse angles cannot be supplementary. Okay, so inductive, a 100-degree angle is obtuse, a 120-degree angle is obtuse. They add to 220, which is more than 180 degrees, so they're not supplementary. So this one we're just using an example. Okay, but like, does this cover all of them? No. Okay, it just gives one specific example. Now, if you use definitions like, okay, obtuse means, this is deductive, so obtuse means 90 degrees, more than 90 degrees. So if I had two angles more than 90 degrees, the result must be more than 180 degrees. Since supplementary angles must sum to 180 degrees, I have proved two obtuse angles cannot be supplementary, okay? So you're seeing this is based on definition versus this is based on an example. All right, so that's what inductive versus deductive means. All right, so this is kind of, when we're talking about the life cycle in math, this is kind of how we get to higher level math problems, or this is, some of you guys have asked me how math has been developed over the years. Like, who even come up with something like that? This is what happened. So most of the time it starts with a wild guess or an educated guess. Okay, so it's estimate, down, high or low, contextualized. Okay, so these all fall under deductive reasoning. After that, you collect data, look for patterns, record the results, develop a model. So remember when they were saying, okay, let's just try some numbers and just see. Okay, well, let's just try 100 and 120, okay, and see how it works. All right, that would be inductive reasoning. Then you form a conjecture. Okay, this is my guess. After you have the conjecture, you move on to deductive reasoning. Okay, so you're going to use logical reasoning to call and prove. All right, this is what we're going to be doing here in a second, okay? And axiomatic. So these are using, axioms are basically just obvious, what do you call them? Like definitions, or not proofs, but obvious theorems. That's what it is. If you just look at it and you know, okay, obviously that line and that line together make that whole line, okay? So, all of these, okay, are used to prove theorems. So you come up with a proof, then you reflect, challenge, counterexamples, be skeptical, then it becomes a theorem. So all those theorems you've seen, a lot of people had to go through this entire process to get to there. Okay, so here's the law of detachment. Okay, so that's another example of what the difference between inductive and deductive reasoning is. All right, we're going to the law of detachment next. If the hypothesis of a true conditional statement is true, then the conclusion is also true. So this is really easy. Here's an example of that. If two segments have the same length, then they are congruent. Okay? We are given that two segments are congruent, or two segments are the same length, so x, y, well, is congruent to BC. All right, so we know that. Basically what it says is, let's say Miss Garner ate tacos on Tuesday. So she, I don't know, I'm trying to come up with a good one. Miss Garner ate tacos on Tuesday, and so she, wait, let's do this. Oh, if it is a Tuesday, Miss Garner eats tacos. Sorry, that's a good example. If it is Tuesday, then Miss Garner eats tacos. I'm telling you, it is Tuesday. So what do you know? Miss Garner's gonna eat tacos. Okay, so if it's true though, sometimes we'll get into some conditional statements that are not true, and that won't work. The law of detachment just means if they're separated, it's still true. Okay, let me give another one. Let's say on Friday nights we have a football game. Okay. So if it's a football game, guess what? It's going to be on Friday night. So it's pretty obvious, like it just law of detachment means that they're separately true. Okay. So let's go down to the law of, I think it goes up. Oh, I skipped this. Okay, let's go over here. Sorry. So I want you to try this. Between inductive and deductive reasoning, okay, we're going to go back to inductive and deductive. All right, give me an example of some inductive ways that you could show that Mr. James robbed the bank, and some deductive ways. Okay, so pause the video and try that. Remember, inductive is more of like estimate, bound, high or low contextualized, looking at past events, looking for patterns, recording results, versus deductive is like facts having to do with the exact event. Okay, so some examples of an inductive would be, okay, I've seen Mr. James eyeing the bank. I don't know if that's how you spell eyeing. I think you get rid of the E. Eyeing the bank. Okay, and then another one would be, okay, I saw him with a bag. Coming out of the bank. Okay, and then deductive would be, I saw Mr. James hold up a gun and ask for money. Okay, or it could be something more obvious than that. I looked inside that bag and I saw money that was not his. Okay, so it'd be very obvious. All right, sorry. So law of detachment, we already went over that. Again, law of detachment just means that if a conditional statement is true, it's true apart from itself. Okay. So here's another example. So if the hypothesis is true, okay, here's a figure is a square, then if the figure is a square, then it is a rectangle. A quadrilateral ABCD is a square. So ABCD is a rectangle. Okay, so again, that's just another example of law of detachment. Here's the law of syllogism. Okay, syllogism is pretty fun to say and pretty fun to do. Okay, so basically you can combine two different true conditional statements together if they have parts that are similar. So, for example, if P, then Q, if Q, then R, so if P, then R. So you can basically cross out the Q's, okay, that are the same, and rewrite the statement of the two things that are not the same. Same thing over here, right? Okay, we can cross out the Q's, and we're left with P and R. All right, so here's an example. If x squared is greater than 25, then x squared is greater than 20. If x is less than 5, then x squared is greater than, if x is greater than 5, then x squared is greater than 25. So what we can do is we can cut out the two things that are similar, and we can create a new statement. So if x is greater than 5, then x squared is greater than 20. All right, and you can use this to even prove things. Let's say I wanted to prove this. This is enough to, by the law of syllogism, to prove that these two things are true. All right, so let's look at the statement. If a polygon is regular, then all its angles in the interior of the polygon are congruent. If a polygon is regular, then all its sides are congruent. So we can cut out the polygon is regular part, okay, and combine these two, all right? And someone's gonna ask me, I'm sure, okay, someone's gonna ask me, I'm sure, like, well, which one, does it matter which one's if, which one's then? No, it doesn't. Okay, so I'm just gonna pick the first one just because it is first. So I would say if all angles in the interior of the polygon are congruent, then all its sides are congruent. Nope. Okay, so that's it. So hopefully this helped. If you have any questions, please feel free to reach out. Some of the stuff, especially the law of detachment, kind of throws people off. So if you need anything, feel free to reach out. But make note cards. These are vocab words that you're going to need to know. All right, I'll see y'all soon. Bye.